This is day 3, graphing reciprocal functions. So what we're going to be looking at today is what begins our look at rational functions and how to graph them and properties of their graphs. F of x equals 1 over x is the parent function of all these. The shape of this graph is called a hyperbola. We have axes of symmetry, even though those don't come up too much. The domain and range here will change as this function changes, so it's not always just non-zero numbers. And for where it's not defined, these are also called asymptotes, is how you're going to typically see these listed. And for this function, 1 over x, for the x equals 0, that's the vertical asymptote here. And for f of x equals 0, that's the horizontal asymptote. The lines that the graph approaches but never touches. For our first example here, it asks us to determine where it's not defined. That's as simple as taking the denominator and setting it equal to 0, because you cannot divide by 0. So in this case, I would probably solve by factoring, so x plus 8, x minus 3, and set each of the factors equal to 0. So the values that it is not defined for would be negative 8 and 3. These are values that x cannot be. These are values where if you put this in, the function is not defined for those values because you get a denominator of 0. Alright, that wraps up that example. On this next problem, what we're going to do is we're going to identify the asymptotes. You can actually do that from what the function is, not having to see the graph. To do that, you will figure out first the vertical asymptotes by taking the denominator, which is x minus 2, and setting it equal to 0. So that's one of my two asymptotes here. Is x equals 2, and that's the vertical one right here. The horizontal one will be f of x equals 0. Now the reason why it's 0 is because the function is like plus 0 out to the side of it. There was no k value here. So it's going to be f of x equals 0 is your horizontal asymptote. Alright, now moving on to domain and range for this one. For the domain, this is going to be x values such that x does not equal 2. So I put a little equal sign with a slash through it. For my range, it's going to be f of x such that f of x does not equal 0. And this is coming straight from what the asymptotes were. We could have any other x value than 2. It could be any negative value, it could be any of these values to the right of 2, it just can't equal 2. And similar for the range, it can be above and below 0, it just can't be 0 in this case. So there's my asymptotes and my domain and range. Now I'm going to go ahead and graph this one. When I say graph, let's just go ahead and use the calculator to get a graph going here. So what I'm doing is I'm typing it into y equals on my calculator. Then we'll state the domain and range. So y equals negative 4 over. Be sure to put parentheses around your denominator. This is not needed if you're doing alpha y equals and typing it in as a fraction. But the way I'm doing it, I'll put x minus 2 in parentheses for my denominator, close that off, and then type in the minus 1 when I'm typing it into my calculator. Now I'll go ahead and graph this function and see what's going on with it. Right, got that done. I can identify asymptotes from here. I'll actually just kind of do that by hand. My vertical asymptote is going to be x equals 2. Because if x minus 2 equals 0, x cannot equal 2. So here we go. And really you should always use a dashed line when sketching in your asymptotes because it's not a part of your graph. And now for my horizontal asymptote, when I look over here, I see that it's actually not the x-axis. It actually crosses over that. It's actually going to be f of x equals negative 1. So I'm going to go ahead and graph f of x equals negative 1. And now what I can do is I can use the table of my calculator to get some values to finish up this graph. So I just graphed some points right here. I got these points from going to the table in the calculator. And I'm going to go ahead and fill in my graph here. What's important to realize, the graph will actually never, ever touch the asymptotes. It will look like it does as you go further along, but it never actually gets there. That would be an error because you'd be dividing by 0 or you'd get 0 by way of division. Neither way is possible. So this is my answer for the graph. Now we're going to state domain and range. I'm just going to do that right here on the grid. For the domain, it's going to be x such that x cannot equal 2. Yet again, for my range, it's going to be f of x such that f of x cannot equal negative 1. And I'd be done here. Alright? So there's my answers as you see. That wraps up today's lesson. Please let me know what questions you got.